This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Today's discussion centers around a fascinating educational tool, the free Particle Wavepacket JavaScript simulation applet HTML5. It's designed to visualize complex quantum mechanics concepts. What initially drew you to this particular simulation?
The ability to make abstract quantum phenomena like wave packet spreading tangible and interactive for students is what intrigued me. It's a challenge to teach these concepts effectively, and this applet offers a powerful solution.
Exactly. It's not just about seeing the wave function, it's about manipulating the parameters and observing the consequences. How does the simulation handle the inherent uncertainty principle?
Brilliantly. The applet allows users to adjust the uncertainty in the particle's momentum and position. By changing this, students witness firsthand how it affects the wave packet's spread, directly illustrating the uncertainty principle.
That's a key advantage. Let's dive deeper into the specifics of the applet's functionality and its educational impact. The applet is described as an interactive JavaScript-based simulation embeddable in web pages using an iframe. Can you elaborate on its key features?
Yes, the iframe integration is crucial for seamless use in online learning environments. Beyond that, users can switch between viewing the particle's momentum or position representation and toggle between viewing the normal filled graph and a graph showing the real and imaginary parts of the wave function. This allows for a multifaceted understanding.
The ability to visualize both momentum and position representations is particularly insightful. How does this contribute to a deeper understanding of wave-particle duality?
It directly addresses the wave-particle duality. Students can see the particle's behavior represented both as a wave, the spreading wave packet, and as a particle through its position and momentum distributions. The interplay between these two representations is key to grasping the concept.
The simulation is directly linked to a Schrödinger equation. Can you explain the relationship between the equation and the spreading of the wave packet?
The Schrödinger equation governs the time evolution of the wave function. In the case of a free particle, the solution shows that the wave packet inevitably spreads over time. The simulation visually demonstrates this prediction of the equation. Adjusting the uncertainty parameter changes the initial conditions, which in turn affects the rate of spreading, as predicted by the equation's solutions.
So the simulation isn't just a visual aid, it's a dynamic representation of a fundamental quantum mechanical equation in action. That's quite powerful. The applet targets both teachers and students. What are some of the key learning goals it effectively addresses?
The simulation helps students visualize the probabilistic nature of quantum mechanics. The fact that the integral of the squared modulus of the wave function always equals 1 reinforces the idea that the total probability of finding the particle somewhere in space is 100%. It also helps them understand the relationship between uncertainty and the spread of the wave packet, a direct consequence of the Heisenberg uncertainty principle.
And how does the simulation's interactive nature enhance the learning experience compared to traditional methods?
The interactive element is key. Students aren't just passively observing, they're actively experimenting, changing parameters, and seeing the immediate effects. This active learning approach significantly improves comprehension and retention.
The applet is credited to Wolfgang Christian, Tanwei Xiong, and Lu Kang. The website also features a vast collection of other simulations. What's the significance of this broader resource pool?
The extensive collection of simulations demonstrates a commitment to open-source physics education. The availability of diverse simulations covering various physics topics allows for a comprehensive and interconnected learning experience. It's a valuable resource for educators and students alike.
It's a testament to the power of collaborative, open-access educational resources. The content is licensed under the Creative Commons Attribution Share Alike 4.0 Singapore license. What are the implications of this open licensing?
The open license promotes widespread accessibility and encourages adaptation and further development of the simulation. It fosters a collaborative environment where educators and developers can contribute to improving the resource. This is crucial for keeping educational materials relevant and up to date.
It's a model for how educational resources can be shared and improved upon collaboratively. The accompanying study guide includes a quiz. What are some of the key questions it asks, and what insights do the answers provide?
The quiz questions test understanding of the wave packet spreading, the visualization of the wave function, the significance of the probability density function integrating to 1, and the relationship between uncertainty and wave packet spread. The answers reinforce the core concepts demonstrated by the simulation.
It's a valuable assessment tool to gauge student comprehension. The study guide also includes essay questions. What are some of the key themes explored in these questions?
The essay questions delve deeper into the significance of the wave packet model, the relationship between the Schrödinger equation and wave packet spreading, the use of the simulation to teach wave-particle duality, and a comparison of classical and quantum descriptions of a free particle. These questions encourage critical thinking and a more nuanced understanding of the concepts.
They encourage a more in-depth exploration of the underlying physics. The glossary defines key terms like wavepacket, Schrödinger equation, uncertainty principle, and wavefunction. Why is a glossary so important in this context?
A glossary is essential for clarifying potentially confusing terminology. Quantum mechanics uses specialized language, and a clear definition of terms is crucial for ensuring that students understand the concepts being discussed.
It ensures clear communication and avoids misunderstandings. The document mentions sample learning goals and research sections, but the text is missing. What kind of learning goals and research directions would you suggest?
The learning goals should focus on specific, measurable outcomes, such as students being able to explain wave packet spreading, apply the uncertainty principle, and interpret the probability density function. Research could explore the effectiveness of the simulation in improving student understanding compared to traditional teaching methods.
That's a crucial aspect for evaluating the simulation's impact. The FAQ section addresses common questions about the simulation's functionality and purpose. What are some of the key questions and answers?
The FAQ clarifies what the simulation demonstrates, how to explore position and momentum concepts, the significance of the uncertainty slider, the meaning of the probability density integral, and the simulation's creators and broader resource availability. It provides concise and helpful information for users.
It's a valuable resource for quick answers to common queries. The website lists many other simulations, including those on magnetism, mechanics, and electromagnetism. How does this breadth of resources contribute to the overall learning experience?
The variety of simulations allows for a wheelistic approach to learning physics. Students can explore different concepts and connect them to each other, building a more comprehensive understanding of the subject. It's a valuable resource for both individual and classroom use.
It creates a rich and interconnected learning environment. This discussion has highlighted the significant potential of the free Particle Wavepacket JavaScript simulation Applet HTML5 as an educational tool. What are your final thoughts on its impact on physics education?
I believe this applet represents a significant advancement in physical education. Its interactive nature, coupled with its clear visualization of complex concepts, makes it a powerful tool for enhancing student understanding and engagement. The open source nature further amplifies its impact, making it accessible to a wider audience.
That was a great discussion. Thank you for sharing your expertise.